are going to talk about calculating the half-life. And this one has a little bit of math, but it's not too bad. So the half-life, or we can say T with a subscript half-life, is the time that it takes for half of a radioisotope to decay. So at time 0, we have all of our sample. At time 1 half-life, we have half of our sample. Half of our sample has converted into something else. At time 2, half of that sample has converted into something else. So every time we're cutting our sample in half, that's the half-life, the time it takes for half of our sample to decay. So this follows an exponential decay type of curve. Have you used those in math? Exponential? Yes. Okay, so this is an example of that. So every half-life, you cut your sample in half, and that will give you exponential decay. So there's some fancy equations that we can use, or we can just kind of reason. This is a kind of a reasoning problem. Have you used half-life in math? Have you talked about? Okay. Okay. I guess this is the other topic. So if we look at a list of nucleotides, these radioactive nuclei.
Do I need to memorize these?
No. Okay. You're just looking for a pattern. So I forgot, this is the other topic. So there's 2 in here. So we were looking for which one is more radioactive. So initially, the things that are most radioactive have the shortest half-life. They're going to last the shortest. They're going to decay the quickest. So if we look here, which of these is going to be the most radioactive isotope? Which one has the smallest half-life, the smallest number?
Beryllium.
Yeah, good. 6.7 times 10 to the minus 17 seconds. So this is a really small number. That means it's going to decay immediately. It's going to give off radiation right now, right in your face. Then what else? We have another seconds. So that's going to be the next one.
Beryllium 11.
Beryllium 11, good. Let's see what else we have. Seconds.
Probably the fluoride.
Fluoride. Oh, hours. Okay, I agree with that. Hours, 1.8 hours.
And then maybe not.
What's Na? Sodium. Okay. The sodium is more hours, but so we have to watch. For this, we have to watch units and the size of the number. Okay. What else? What's the next one you think? What would be the next most radioactive? Days. Okay, good. So up here, days. So beryllium 7 from this list. And then what would be next? Carbon. So this one's years. Times 10 to 3 years.
Hydrogen.
This one has no times 10 to this, so this would be the next one. So this one is going to decay in after 12 years, half of your sample is going to be gone.
Is this going to be on the Alex though?
Yes.
Okay.
Something like this. So you're going to get a list. It's going to give you like 4, and you're going to have to rank them.
Oh, okay. So we have to know.
You just have to, like, it's not, you're not going to have to memorize this one, but you just have to say, oh, if it has a smaller number, smaller half-life will be more radioactive.
Okay, I see.
Yep. So then there's this one, then carbon 14, that takes a lot of years to decay. And then beryllium 10, that one has the largest half-life.
It's like a million years or so.
What's that? Yeah. So that one, it's going to be radioactive, but you're not going to see particles constantly coming off of that. Okay. So then, when we're doing this type of question, we also have The number of half-lives. So after one half-life, half of our sample is gone. So after 2 half-lives, how much of our sample has gone? How much is remaining? How many half-lives have we done in 2 half-lives?
Oh, 1/4.
Yeah, we will have only 1/4 left. So we can think about it in 2 ways. So one is we can just think about it as 1/4. Or- Yep.
Times it 2.
Yes, we can take the bottom number. And we're not gonna times it by 2. We're gonna put an exponent on it. So we have 2 half-lives that have happened. So that's the same as 1/2 to the 2. So 2 half-lives is 1/2 to the 2, which is the same as 1/4. Okay, so how about 3 half-lives? So we've done 3 half-lives. Good. 8. Good. So that's the same as 1/2 to the 3 half-lives, which is 1/8. So you can either reason through this, or you could write something like this on your note card.
Okay.
Does that make sense? So either way. But this is what's happening. This is like the reasoning. We've got 2 half-lives. We've cut our sample in half twice. We've cut our sample in half 3 times. For 4, we've cut our sample in half 4 times. Which is the same as 1/2 to the, we've done 4 half-lives. Which is the same as, what's 2 to the 4? Who knows that one? 16. Good, and we're following this pattern. And then 5, let's try. I think I've only seen to 6. But if it comes up that it's more, you're still gonna follow this pattern. So we have 5 half-lives. That's the same as, sorry?
32.
Okay, thank you. 2 to the 5th, which is the same as, I still haven't figured out this pen tool. Let me try this in for a minute. 1/32. Okay. And then the last one is on this table. We could keep going forever, but we're not going to do that. Okay, so that's, thank you. 1/2 to the 6 half-lives, which is 1/64. Okay. Okay, all right, very good. Okay, so how about this problem? How long will it take for a sample of xenon 127 to decay so only 1/16 of the xenon 127 remains? And then we also have this information. The half-life of xenon 127 is 36 days.
Okay, so 18.
So 4 half-lives? Good. So
I have no idea how to do
1/16. So maybe it's just tell us that for every half-life. So she says that we had 4 half-lives because 2 to the 4 is 16.
Okay.
So we've had 4 half-lives. We've had 4 half-lives. So if we've had 4 half-lives, this is how long 1 half-life is. So how do we get 4 of these? Multiply by 4. So 36 times 4. I don't know. This is very annoying. What is 36 times 4? 144. 144? 144 days. So if we have 1/16 of our sample left, it must have been 144 days since we started with our sample. So you just have to figure out, if I have 1/16, that's 4 half-lives, so that must be, and then you multiply that number by your half-life.
I see.
Okay. All right, so that's the last topic. We have the rest of class. So go ahead and work on Alex and the lab. If you have questions on Alex, I can help you with that or the lab. Or make sure next time we're doing lab 13, lab 13. So make sure you have your pre-lab done for lab 12.
Oh, yeah, I got the report I got. Just need to do the post lab.
I see.